Hi guys, welcome to this another another video lecture of automotive engines and emission control. So this is Dr.M.MOORTHI working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So in this video we are going to discuss about a topic called a knock in SI and CA engine. So knock in CA engine abnormal condition, what it means. So knocking is it's a it's opposite to the normal combustion process in C or in a CA engine, that is the CA engine or SI engine. Generally we take it as IC engine, internal combustion engine. The knock is the negative factor during the combustion process. So in CA engine, that is the compression ignition engine, yes, delay period increase, the amount of fuel injected and accumulated in combustion chamber increases. A simple term for to describe knock is, so if you take SI engine or CH irrespective of the type of engine, so we have a delay period once the combustion process is started. So there is a delay period in which there is no combustion is taking place or there is no burning of fuel is taking place, so that the intaking the fuel air or the air fuel mixture or a fuel is accumulated in the combustion chamber. So this accumulated fuel once starts to burn with or is self ignited, and then it produce the abnormal combustion, and during that phase it create or it develop more pressure and temperature inside the combustion chamber. So it is called as a knock in CA engine and then SI engine. So a very high temperature and pressure is generated by combustion of this large amount of fuel is known as knocking or detonation in CI engine. So the accumulation of fuel during this large delay period, it will create a very high pressure. So this is known as knocking in CI engine. So this high rate of pressure rise create the pulsating combustion which produce heavy noise inside the combustion chamber. So in CA engine, knocking occurs during initial phase of combustion, that is as delay period is completed and uncontrolled combustion. So once this during the uncontrolled combustion process, the accumulation of fuel inside the combustion chamber during the delay period it starts to burn and start to ignite. So during this phase it's create the noise inside the combustion chamber, so it create a knock or detonation. So see here the pressure, the crank angle diagram of CA engine with and without knocking. In the first phase, in the see here the start of injection, that is the fuel injection, and then the pressure getting increased, and then it starts to and then it goes up. Goes up means there is a smooth combustion process is taking place, and then once the fuel is completely burned, it attains the maximum pressure and it starts to down means the pressure is getting released during the expansion stroke. This is the normal combustion. For the abnormal combustion, so there is a deviation or the differentiate in the pressure rise. It is the not even, so it is the uneven pressure rise while the fuel is burned, and then after that it goes down. So this is the different the pressure crank angle diagram for the normal and the abnormal combustion process. So there are numerous factors that affect the knock in the CI engine. So that starts with the variable increases the effect on knocking tendency. So this is the factor, and then the fuel, that is the CT number increases, the knocking will be decreased, and the intake fuel jet water temperature and the knocking will be decreased. The intake pressure is increased, the knock will be decreased, and then load, that is the load, and then the knock will be reduced. And then injection, while the increased injection pressure means the reduced knocking tendency, the likewise increased injection advance angle, and it increase the knocking in CI engine. So this increased injection advance angle means it increase the knocking, so it produce the more noise in the combustion chamber. And the next one is the engine size, that is the increased engine size means decreased knock tendency. The same wise increased speed means increased knock. And then next, if you have higher compression ratio, that is for any engine means it reduce the or it decrease the knocking in the combustion chamber. So there are numerous factor, it directly affect the knocking in the combustion, knocking during the combustion process. So that while design the combustion chamber, we have to consider these factors so that we can minimize as much as possible the knocking tendency in the in the chamber, combustion chamber, during the combustion process. Thank you.